Hi, fifth grade. Let's dive into subtracting fractions with unlike denominators when they may have a mixed number involved. So we are going to be working on subtracting fractions, but just like when we do regular subtraction of whole numbers, there may be times that we need to do regrouping or some borrowing from a neighbor so that we can subtract correctly. If we look at this problem, 3 and 2/6 minus 1 and 5/6, let me underline this problem here. We see that they have common denominators. However, when we go to subtract our fraction parts, we can't do 2/6 minus 5/6. 2 is smaller than 5. So instead, what we need to do is rewrite our mixed number. Anytime you have a fraction above that is smaller than the fraction below, you're going to make use of an improper fraction to allow you to solve. It's one way that we flexibly use mixed numbers and improper fractions to allow us to work with different operations. So one way that you can think about this is like pies. We have 3, 1, 2, 3, and 2/6 shown here. 3 whole pies and 2/6 of another pie. I can take one of the whole pies and I can divide it up into 6 equal pieces. Even though it's still a whole pie, I know that I can write this as 6/6. So 6/6 here can be added to the 2/6 that I already have to give me 8/6 altogether. So I still have 2 whole pies, 1, 2 here. So I have 2 and 8/6 all together. It means the same as 3 and 2/6, but now it's written in a form that I can easily subtract 1 and 5/6 to find my answer. 8/6 minus 5/6 equals 3/6. 2 minus 1 equals 1, giving me my final difference here. Another way you might think about this is by changing the mixed numbers completely into an improper fraction so that you just have fraction subtraction problems. So in this problem here, 3 and 4/12 minus 1 and 6/12, same thing we noticed, common denominators. However, it can't do 4 minus 6. So I can change both of these into improper fractions and then subtract. Remember, to change a mixed number to an improper fraction, we take our 12, we multiply it times our whole number 3, then we add our numerator 4. 3 times 12 is 36, plus 4 more gives me 40. So I rewrite this mixed number as the improper fraction 40/12. I can do the same thing to my other mixed number. 12 times 1 equals 12, plus the 6 in the numerator. 12 plus 6 is 18. So I have 18/12 as my next improper fraction. Now that they're both improper and they have common denominators, I can look at step 2. 40/12 minus 18/12 gives me 22/12. Now that is still improper, but we know how to fix that. To change an improper fraction back into a mixed number, we use that fraction bar as our division symbol, 22 divided by 12, to give us 1 and 10/12 here. We could even simplify that further to 1 and 5/6. Let's look at one more example here where we have unlike denominators. All these different skills that we are learning with fractions can be combined together. We know the basic principles of a fraction, so we can use them, adding or subtracting. So I have 87 and 1/2 here, minus 82 and 3/4. Well, my denominators are not the same, but I know that 1/2 as an equivalent fraction is 2/4. So I can rewrite my problem here as 87 and 2/4 minus 82 and 3/4. But I run into one more problem when my 2 up on top is less than the 3 down below. I can't subtract. So instead, what I'm going to do is rewrite this top fraction. I like to borrow from a neighbor or do a little regrouping here. I'm going to change this 87 to 86. And I'm going to take one whole from that 87 and rewrite it as a fraction. Remember the pie that we cut up? That one whole can be cut into 4 equal pieces because 4/4 is the same as 1. I chose 4/4 because my denominator is 4. So I'm going to take my 2/4 that I already had and add the 4/4 that I borrowed from my whole number. So 2/4 plus 4/4 gives me 6/4 here, and now I have 86. So take a look at my new problem. 86 and 6/4 minus 82 and 3/4. Now I can subtract. 6/4 minus 3/4 is 3/4. 86 minus 82 is 4. So 4 and 3/4, my final difference. So lots of steps, lots of skills that we're learning here 5th grade, but they all work together. If something is true about fractions that we learned a couple of weeks ago, it remains true even as we get more and more complex. We'll practice this together. Thanks, guys.